Okay, here we're going to integrate 1 over x minus 2 to the power of 3 halves. We have to find out if this converges or diverges. And if it converges, what does it converge to? So whenever we have something like this where you have infinity, we have to take the limit as t approaches, or any variable, as whatever variable approaches infinity, and then put the variable in there. So we have this, and the integrand, we don't change that. 3 halves power dx. Okay, now we could go ahead and start solving this. How would you solve this? Well, maybe we could change its form to x minus 2 to the negative 3 halves. This is equivalent. Whenever you have a negative exponent, that's just sending it to the denominator. Now we can do u sub. So we're going to let u equal what's inside, which is x minus 2. du becomes dx, because this is 1 and that's 0. Make that back substitution. Don't forget the limit here. We're always carrying the limit down. So this is u to the negative 3 halves du. Now go ahead and integrate this. What do we get? If we add 1 and then divide by that, we get negative 2u to the negative 1 half. We can make back that substitution, which is x minus 2. Negative 2 times x minus 2, all to the negative 1 half power. If you have something to the negative 1 half power, that's sending it to the denominator and square rooting it. So this is the square root of x minus 2 that's being multiplied to this. Square root of x minus 2. We don't have a plus c because we're evaluating. We're trying to evaluate this integral here. So we have t, or 3. The limit as t approaches infinity. So on one side, we're going to plug in the infinity. On the other side, we're going to subtract the plugging in 3 version. So we have negative 2 over square root, and you can think of it as infinity minus 2, and we're subtracting negative 2 square root of 3 minus 2. That is just 1. 3 minus 2 is just 1. Square root of 1 is just 1. So this is negative 2. Negative 2. We're subtracting because that's how you solve definite integrals. You subtract whatever you have at the bottom that you plugged in. So this is an addition of 2. Plus 2. Whenever you have infinity, the limit as t approaches infinity, we have t here, remember? This is t, and it's the limit as t approaches infinity of this. It's the limit as t approaches infinity of this. So if you have infinity here, that goes to 0 because it's in the denominator. Divide something by something so large that keeps getting larger and larger, it just goes to 0. So our answer is 2. This thing converges to 2. Converges to 2. And for completion's sake, you could put as limit t approaches infinity.